So for understanding this whole course about how different things combined, I think this is a very good picture. I already put on the Canvas page. That is the first picture. Some people may think that is a bit overwhelming, and then some people may think that okay, exactly what this is about, and then I label 1, 2, 3, 4, 5. It's very hard to capture what I mean by flow chart because of the iterative nature. And then this picture in different version we have been published in different papers for now more than 15 years, I may say. So if I can go back to my PowerPoint. So you look at this picture, even though you don't have my PowerPoint slide because of it's already on Canvas. But if I go back to my PowerPoint, and then to just show you back what I mean by this picture. This is the current version, but I write down to 2021. We will come back later. But there was another version, 2009. And then in the first version, the paper published was, I forgot to name the paper, but you can read about that later in my reference list. The term was called simulation-based linearization. Well, it takes some time to explain what this word means. This word was coined by my long-term partner, Professor Moy Depp, first in Indian Kanpur IIT, but later, I think he spent so many years in Michigan, so Michigan State University. So we will come back to talk about this term later in the course when we talk about data mining. But this picture pretty much, even though it's an old one, but if I label the new topics that we are going to cover, or the topics, the technological topics that we are going to cover in the course, I think it's still fitting very well. Is processing data using process mining is more like an input to simulation modeling. And then no matter we talk about multi-objective or single objective, so through the optimization, you go to the middle box. So you connect to the optimization. And there in the optimization, you start to use some machine learning AI methodologies. So it's still more like academic discussions when we use a genetic algorithm, evolutionary algorithm. Are they really artificial intelligence? It used to be genetic algorithm belonged to one branch of artificial intelligence together with a fuzzy logic and neural network. But nowadays, people start to say that our genetic algorithm should be just an algorithm and not AI. Anyway, but when you find a combination with an artificial neural network, that is the machine learning. And then data mining and machine learning, they share quite many of the algorithms, but they also have some difference. Especially, I think machine learning is more about really learning something and then can replace the human being. That is more about the machine learning and AI part, but they are really related. So later we will talk about visualizations and decision support and so on. So this is the later part after the so-called knowledge excitations, extractions, and so on. And then of course, for you to make modeling, you also need to understand this production system engineering business process principle. So I think this is an older picture. We already started to publish it in 2009, but it captured pretty well what we mean by how different things in this course cover can be combined together. And sometimes the flow is not that straightforward. You can have an iterative, and sometimes you can even make some preliminary optimization, even you do the modeling. And then of course, you can have the knowledge excitations helping the optimization. So the flow is not that straightforward. It's not simply a linear serial flow, and definitely it's more difficult to capture in the flow chart. And that's why in recent years, the first similar picture was published by my PhD student, Katarina. I think she published her thesis in 2019. I think she registered with Stockholm University. But this is an updated version because I tried to make it clearly into two loops. So for those of you who study with me about simulation-based optimization, here SBO simply means a simulation-based optimization loop. And then for just the blue side, it already can be an effective methodology to support decision making. So you have a problem, you define your problem, and then we start with number one here, and then here we talk about target performance. So no matter you're talking about designing a new system or even product, healthcare business, whatever, you begin with some certain target performance, something you want to achieve. We talk about the goals, okay? And then many people will misunderstand that when we talk about decision making, especially if people talk about multi-object optimization, they will think that decision making is more like a Doctor Strange. So to the end, you find something you implement, you find a single solution. But I want to tell a very important message here. I think it's good to have a help of another slide here. Some of you have seen it before in my earlier course, but I need to repeat this one because this one is so important. We talk about the real world. You can never really study the real world by capturing everything, and you never really know about the real structure of the real world. You can only have simplification, abstractions, or modeling. They have a different meanings, but let us just think about that. We just capture the essential aspect that we want to study about the performance, for example. And then whether you are making a mathematical model or simulation model, that is not the key relevant here. But you know, many problems, they are not optimization problems. So to the end, maybe you not really try to optimize something. And those kind of models, you can just run different type of a what if, even qualitative analysis. But if you convert the problem into optimization problem, then you need to define decision variable and objective functions. And in some cases, we will even have constraints. We talk about in the basic optimization courses. And even if you study mathematical optimization, linear program with Masood, you will know about what I talk about here. But something that you shouldn't forget is when you define the model in terms of the abstractions. So if you don't make the decisions about what decision variables to be included, it actually affect your abstractions. So think about that. If you design a model to solve a problem, and then you know that some of those variables, they are able to be changed, to be controlled, you're already making some decisions to select those decision variables. And then you also define your goals to put what are the objective and what are not the objective, what should be the objective functions, or some of them are secondary. Maybe you can put them into constraints. So in this process, we are already doing quite much decision making. And this is a very important concept to understand because many people, they don't understand this concept, is that they don't know what they want to achieve when they define the model. And they think about decision making is very much about by the end of the whole process. And then in my loop here, I emphasizing number one here. Number one, you're already making decision making. But this decision making is not about finding the final solutions to make any implementation. It's about defining what will be the decision variables, and what will be the objectives, your goals, and also secondary, what are the constraints. Okay, so this is a very important concept to understand compared to, I think if you read any other classical optimization courses that you start with the mathematics, that the objective will be more like given. Okay, now you have X, Y, Z, they are the variables. So when you're solving real problem, how you decide what are the X, Y, Z variables and what are the objective. This is already a crucial questions and it involves already decision making. And then to the end, you will affect, that's why number two here, abstraction modeling. Okay, so the abstraction is really defined by your problem nature, but also the decision variables. So think about that. If your decision variable can only address to a certain level of the problem, then of course there is no point for you to make the model to be more details, to go down to another level. But another way around will be if you didn't decide certain decision variables should be included, but later you include back to the problem formulations, then maybe your model is already in the wrong abstraction level. So this is something important to understand. So later in the course, of course, you will see more practical examples. So now I think I'm simply giving you a little bit more abstract information. And then this loop number 3 here. So you run optimizations, you get the Pareto front. I think you have all tried it before with effects analyzer in other course. I think you understand what I mean. And then of course, this is the number 4 is the classical loop, is the simulation-based optimizations. But don't forget that you need to verify and validate. You need to make sure that your model is built correctly in terms of coding. So later, when we do the C++, of course, we will do quite much of verification because you intend the model should behave in certain way. And then in simulation literature, we talk about conceptual modeling. Before you build any model, the very short definitions of conceptual modeling is a description of the model. So you don't need to build anything. You don't need to write any code, but you not need to describe about your model. That is the description of your model. And then you need to verify that the thing that you code, you put the C++ program in, you make the model to run. Do they really, the model, does it really conform to what you expect in your descriptions? So if you make something wrong, if the logic is not correctly coded, if your program doesn't work, so you fail in the verification. So this is something that how you check your simulation against the problem formulations. But let's say that your model is correctly built, but then listen to me now. You don't sure that whether your model is the right model, okay? You can build the model correctly, but you can build the wrong model. And that is the matter of validations. And validation pretty much means that, yes, you build a model, but either the model gives you a wrong answer or not actually addressing the original problem formulations. So this is the difference of a verification and validations. So this loop, I think if you study with me or Matthias with a simulation-based optimization, so you have a somehow already certain understanding. But then I think in this course, I think the orange part, now I label, I'm sorry that I can never really define for you these terms, but the KDO is a new research term called the knowledge-driven optimization. So it's something related to knowledge. So on the right-hand side, this is something more new, and then you will try more in this course will be from the solutions, you will do the knowledge discovery. Sometimes you do it, you can do it manually, and then you can visualize the data. So by visualization itself, you can already extract some knowledge, but those knowledge, usually they are in certain tacit form, not explicit form. And also, in many cases, the knowledge that you can gain with visualization will be also subjective. But we have something more objective, even though you can have a bias. That is using knowledge data mining, using machine learning. And this is where the data mining and advanced algorithm that we talk about will become to apply here. And then all solutions or part of the solutions, what you gain will be from the knowledge discovery, you extract some rules. We are interested in some explicit knowledge that we can present, we can save. Now, the word preferences that come here. So the rules can send back to the visualizations. And then if this is the visualization, there will be pretty much interactions with the human being. So here we talk about the decision maker as the human being we talk about. The interaction will be presenting the rules, visualizing the rules, but which part of the rules and which part of the visualization to show, there will be a lot of interactions. And here, the keyword will be preferences. And sometimes we talk about partial preferences because of the user, the decision maker, may not know exactly about the full picture about what preferences to make. That's why we use the word partial preferences. So the right-hand side, the orange side, we collectively call it the KDO. And then it's the same here. It will be iterative. And sometimes you can even present this picture. I try to show that this is can be something more like an infinity loop. I draw in this way or modify Katerina's picture in this way is to show that you actually have two loops, but this loop can be like even iterative. So you can go back when you find the rules, maybe you find that the solutions are not very satisfactory, something that you're not sure whether the model is working correctly. Then from your fifth number 5 loop here that you may even need to go back to number 2, even number 1. And that's why, as I mentioned, it's very difficult to try to capture this picture using a flow chart. This definitely is not a single flow. It's a pretty much an iterative workflow here. So this is the idea about the combination of different technology I present in different ways. And similar picture you can find in other, now I can skip this part. I already talked about this even in another course. And then, no, I don't have the picture now, but this is the, I don't know, I should call it textbook, but I think I can't find one single book to cover as much as possible. I think one day I should write one myself together with some college. But I think it's good to show you about this textbook. You find in the essential reading in Commerce. So, and then it's easily accessed from the Uppsala University Library. So you can have the online version. This is a quite recent book, 2019. I think from some want both work in industry, but also academic. If I'm not wrong, I think in Lubbock, in the UK. So this book is about simulating business processes. But then in the subtitle, he clearly defined what we mean by descriptive, predictive, and prescriptive analytics. So these terms we defined it before in other courses, but now once again, so descriptive is about we try to analyze what has happened, or maybe even what is happening now. So, and related term that is not shown here is diagnostic analytics. So troubleshooting or try to find some pattern in your historical data that usually belong to descriptive. And then people have been doing descriptive analytics for many years since the era of statistics. So the very basic idea of statistics is about descriptive analytics. But there seems more advanced statistical tools like AI, neural network particular, but other type of like support vector machines, anything that can give you these predictive functions. You try to project into the future. But the technical terms here, you know, this prediction, there is no magic. The magic, if you really need to call it magic, is you try to have some function approximations relating the input and output here. Now, I think for this book, it doesn't explicitly say about the input and output, but it's pretty much that way. For the machine learning algorithm, you have the input and the output, and then you try to map the relationship using some functions approximations. But the major purpose is how you can train your model with the seen data, and then later you can try to predict something on unseen data. And this is, of course, something for the future or something you want to try, what would happen. And this is the very basic idea or the purpose why we have predictive analytics. And finally, prescriptive analytics is always related to some optimizations. And then it's not only about the optimization process by itself, it's also about analyzing what is optimized. So it's not about this keywords here. If someone wants to ask me, okay, is there any one book that I would recommend you to read through in the whole course? Then I think this will be the one. And then there will be many other books I recommend. You might recommend reading many papers. And then I don't really expect that you need to read through all of them. But I think this is a good book to read because it pretty much captures most of the keyword, the technology we will talk about in this course. Some of them may be rather basic, and then maybe not that relevant because in this book, it doesn't talk about facts analyzer, for example. But anyway, I think if you want to go refer to one single book, I think this is something I recommend. And then relate to that, you know, the previous slides, we talk about definition from the textbook. I like to use this picture from Intel from a white paper. So the thing we talk about descriptive, diagnostic, predictive, you really can see that from this white paper, you try to divide into different level of analytics. And then of course, it also relates to technology. So it used to be already based on this kind of data warehouse, database processing. You could already do this descriptive and diagnostic analytics. But later, when people talk about big data, machine learning, artificial intelligence is more referred to predictive and prescriptive and even the cognitive analytics. So for this course, we will stop in this level, prescriptive analytics. So simulation-driven analyze and decision-making. And then some of the technology talked about on the right-hand side will be used. So you're already familiar with those terms when we talk about it. But I have something to say about another level, is a cognitive analytics. Because of, I think AI is a hot topic. And then of course, cognitive analytics talk about the machine can have the self-learning and even make the decision by yourself. So in this course, we talk a lot about the decision-making by human being. But in the next level will be the machine going to make the decisions, okay? Not even to get rid of the human being. But I have something to say about this cognitive analytics level is, I don't know how many of you in your generation do you watch the film called The Terminator? I think maybe that was a theme in my generation, not your generation, right? So you know, how many of you still remember this Terminator or Judgment Day? Okay, I think the date was 1998, 29th of August, something like that. Okay, when the machines called the Skynet become cautious, the first thing that when the machine become cautious, then the first thing is to try to terminate human being. Okay, try to terminate humanity. That is the theme of the series, or the theme called The Terminator. But you know, I think when we talk about AI, forget about that. Forget about Terminator. Forget about when the machine is cautious, that it to start to take over and then try to rule out this human being. I don't think this is something that we need to worry. But what we not to worry as a Thomas Friedman, I think the author of the book called it The World is a Threat, in one of his later book, what we need to worry about AI is very simple, is the bug. And that means like the bug that is connecting to the AI software. I think that is something we need to worry in the coming 10 or 20 years. So not because the machine become cautious, but more about the classical computer software bug. And if you let the machine to make decisions, so what happened to those bugs? Okay, that is one thing that I want to talk about AI. But another level will be about who define the goal. You know, the trouble with AI that would cause, of course, we talk about take over human job, but at the same time, there are a lot of theory talk about the AI will also create new jobs. And then if you study industrial analytics, I don't think you need to worry, because you should belong to the future, belong to this knowledge-driven economy that the world is talking about, no matter you talk about Europe, US, or China. So you belong to the future. But the question is, AI will be very loyal to implement the goal imposed by certain people. So if you're building a killer machine, there will not be any moral issue for the killer machine to kill someone. So for dictator, it would be perfect to have the AI killer machines, because then the AI killer machine will never have any moral issue compared with today's human soldiers. That is one aspect. But another aspect is for organization, for company, when we talk about AI here, is who will define the goal. And then in this course, we talk about there will be certain human being judging among the different higher level values and so on. But if you make the decision making automatically into the AI, so who will define the goal? And take one extreme example. I think even though Facebook didn't really admit that, but if you watch some Netflix documentary, there must be certain functions, objective function in their algorithm. They want to maximize the profit. So maximize their profit probably is the objective of their algorithm when they try to process any information that they can get it from the social media. So I think there will be something interesting to talk about AI, and that would be my philosophy here. But come back to here, we will stop in this level. So anything we talk about in this course will be supporting human decision making. Of course, in research project, I'm now leading a research project together with KTH and also some other companies. I think some of you here could also join me in the project. Then in that project, we are going to investigate how we can actually move up to the next level. But when we move up to the next level, we really want to make sure is how human and machine, they learn to each other, and how the human value can be effectively translated to the goals for the AI. And then if the AI makes certain decision, it should be also explainable back to the human being. I think that is one thing I'm leading with some other researchers, AI researchers in Uppsala University. I think it's already too much, but if we go back to the simulation literature, I think sometimes you see these key terms, digital twins, and then for some papers, like this paper called a virtual factory-based data analytics, you simply combine simulation and optimization together, and it will be what we talk about prescriptive analytics. So I think finally, I think this is a very good slide. I think this is my PhD student, he presented this slide 2 days ago in his licence seminar. I think he made this a very nice picture. I told him to send to me. So you can see that the middle part is talk about discrete event simulations. So you already can provide some predictive functions asking what if, and then simulation-based optimization spread to this prescriptive analytics. And finally, the KDO, the knowledge-driven optimizations, can give you not only about insight, but also about foresight to study about the aspect that support to do decision-making for future system. Let me see, now we still have like 10 minutes. I even have one example to talk about it. I think I will come back to this slide later in my lecture. I think now is maybe a little bit early. I want to use the final 10 minutes to go back to talk about canvas. Now, am I still in the PowerPoint? Yeah, now it's good. I'm now in the canvas. So already explained what this picture means. So you will have the enough lectures and also laboratory to fully understand this two dual loops here. We talk about the course content and learning outcomes. And then we touch upon a little bit about this course assessment and grading scheme. I don't really nowadays teach any courses nowadays. I have another course in crypto, but I have told you something about my experience. You know, in other courses, when I teach, that was quite many years ago, Siemens, a prompt simulation. So I had one course to teach the student to program prompt simulations to prepare them in case they need to do some projects. So in that course, the student have only one standard specifications. So more or less, different students will compete with each other. They try to make the similar model, and then they try to benchmark with each other to beat the other group in order to get the best performance, like throughput. And sometimes they try to compete in the working process. I think they learn quite much by this type of competition courses because of they have a certain motivation. They try to build the best model. But as a teacher, I think it's quite boring because you know, like if you have 20 students, I think everyone will present the same problem, present the same background, and maybe the performance of the model will be slightly different. So I think that was one experience I had with that old course. That course is still running, not by me, but by some other PhD student. I think it's still quite useful because I think it's also easier for the tutors to support the students because they're always solving the same problem. And then later, I had another master level course in crypto. The approach will be very different. So if you read something like for this part, I think you can focus on what I try to put up here. And then another thing that is also related to here, I talk about level 3, I think. We talk about reflect to the literature, relate to the literature. Okay, so another approach that I can teach a simulation course is to let the students to read some academic paper. And in many academic papers, they will give you enough details that you can replicate the model. And that is the approach I'm still running. Another course in Crypto is the student, they read the paper, they try to use the simulation software to replicate exactly the same model they find in the paper. They need to first show they can replicate part of the experiment in order to verify the results from the researchers or from the paper. And then that will be the first part. But the second part will be they can propose something they can extend. Now the problem is here because of for the master student, usually when they start with my course, they not even started with a facts analyzer. So many of them, if they have a background not industrial engineering, they don't know even any simulation at all. So the trouble for me is that I can't expect them to do too much extension. And that is why I think when I come to this course, I think that is something very interesting, is that you all have some basic background in simulation based on previous courses. And then in this course, I will give you enough knowledge so that you can extend certain aspects. And that's why the approach to do the project is you are going to select, like my first sentence here, you try to select an existing model cover in the lecture or the tutorial. But then maybe some student will ask me, can you just find any paper that you find will be interesting, that you think that you can extend the paper, repeating the experiment that run by the researcher. So according to the first principle, think free, that you are free to do that. So if you already have a certain background, maybe relate to your own project, I think many of the PhD students here, you have your own project. So you are free to make your own model. So you don't even need to extend the existing model that I have put into tutorials or cover in the lecture. But there will be certain disadvantage. Maybe for PhD students, I think it's okay. They may have more time and maybe have some other support. But for the master student here, if you want to complete the course in time, then I think I need to make sure that the scope of your modeling will not be too big. So if you think about something is too big and too difficult, and something I know that maybe is difficult for you to manage, then I think later in the project supervision, I will tell you maybe you need to reduce the scope a little bit. But this is something I want to control, not because I want to control something, but I want to make sure that during this time period from now to January, you are able to complete a model to a certain extent. You can run optimization on it. You can do some analytics on it in order to complete the course. Okay. So think free is good, but at the same time, you also need to complete the course. Okay. So that's good to talk about. And then I have a different levels. I think I don't try to explain it now. First, I think you may need to read it, to digest it a little bit. And then officially, I think by the end of November, I will start to give you more information about this project. And then you will understand better about what I mean by those existing models cover in the tutorial and the lectures. Okay. And then this will be a pretty complex marking scheme as well. I usually don't do this kind of things, but I think let's try it for this course. So there will be 5 levels. You can extend things in the 5 levels, and then each level will be 20 marks. And then I have some grading scheme here. I like to say that it's usually not very difficult to pass my course, but then the usually is not that easy to get a good grade. And the reason is because of you have a different level to climb. And then for those really ambitious students, if you learn about deep learning, reinforcement learning in other courses. So if you really think that you can apply those algorithms into this course, please feel free to do that. And then I will give you extra credit or bonus if you can do that. Okay. I tried to talk a little bit about deep learning and reinforcement learning in this course, but I later find out it will be already too much. But if you already studied together with like Max Gustafsson professor in the earlier courses, so and then you find that you are able to manage to use it, then you're welcome to do that. So quite much about this course assessment and grading scheme. But come back to the very basic sentence here. If you ask me what you need to submit to this course in order to pass, so 2 laboratory assignments and 1 project work. And then usually I almost always get the questions by the student is how many pages for the report? Okay, so these are the answers. So you don't need to ask me later. So how many pages? That is the first question that students like to ask about report. So 3 to 10 pages, a pretty high range for the lab assignments, and then the 15 to 50 pages for the project report. So you can see that. I'm Chinese, right? So Chinese students sometimes like to have a certain logic that the more to write and make the report figure, that the better grade will be. So somehow I think I have a certain bias. Yeah, I think if you send me a report that is 15 pages, another report that is 50, it's very, very difficult for me to say that the 15 pages report is better than the 50. But at the same time, don't try to write too much just because you think that writing more, you get a better grade. I think, but I give you a better range because I would expect quite many of you need to include many figures, visualizations we talk about. So the range is pretty big. But if you think that you just want to say that you want to go for the minimum, then I think I give you here, it's 15 pages. A few words before I end today. I think a few words about, I'm the main course leader, the lecturer, and also for the C++ part, start next week. And then the colleague, he will help me about the meta modeling. He just completed his PhD using a different machine learning algorithm to train data. I think he's much more skillful than I do. He will help me in the meta modeling part for one lecture and one lab. And then all the tutorials are prepared by Jacob in Eroma. And then I also have Richard with me today, also from Eroma. So they prepared a tutorial that you are using today. So this is with the first time. Let me show you a little bit. I think you find the tutorial. If you don't know how to find it, I can show it to you. You go to modules, and then in the advanced simulations, laboratory 1, and then here you link to the handbook. I think many of you are familiar with the handbook, but maybe not familiar with this new version. So some of you use the older versions. This one is more interactive, prepared by Richard and also Jacob. The old information you find in Simulate, then you don't need to repeat. And then for those of you who haven't really done the optimization, so the optimization, there are certain tutorials. But for this course, you have this custom logic models. So as of today, as far as I know, it's not fully completed. I think I can still see some older information there. And then quite many of them, you have the YouTube videos prepared by Yuko. But then apart from the final one is the production. I think many of them are already ready. And then this is the wheel that you see in the handbook or on the web. But if you go back to Canvas, we will talk about that next week. So today is just an overview for me, okay? So this tutorial, totally, I think 14 of them will cover different aspects. And then if you look at the text, so there are quite much information. Of course, I don't expect you to understand anything here today. We will do it to start from next week. But this picture, I think, pretty good capture about the structure of how those tutorials are put together. Okay. So now I think I stop the recording.